because the illuminated part of the moon is actually, is actually facing space. This would be theoretically every month you have a lunar eclipse. It's not for other reasons because the planes are not exactly fit. But it's a mini, this point where we don't come, is what we call conjunction. Or, in terms of Chazal, molad. Now, as you know, the moon will move around the earth. And as the moon moves, we have different phases of the moon. I'm going to talk in quarters. Obviously, I can talk in days. Over here, the illuminated part of the moon, right? In other words, this part will be illuminated. Right? So here, this part is illuminated. We see nothing. As we move, we see this is what we'll call half moon. Because half of the moon is illuminated, right? And half is not. In other words, think of it this way. This is the amount that you're going to see. This is the amount that faces space. Half of the moon that you see, so at this point, the moon will look to us like this. Okay? Because half of the moon you see is illuminated. You go a little further, and here, the illuminated part is all of your half of the moon. The moon is going to look like this, a full moon. And I know it looks funny, because why doesn't it look like a quarter chip and why doesn't it look like a half?
No. Doesn't the moon get its light from the sun?
Yes.
So how do I not see the moon?
Because part of it is facing the other Earth, space.
From the first one.
Oh, because it's not facing us.
What?
You see, it looks like a circle.
Side.
You have to think of it as a sphere, as a ball.
One side you're flipping.
In other words, you have to think of it as a ball.
In
In other words, it's not a circle. It's a ball, right? So if I chop it in half, in other words, you're seeing the half of the ball. Here, you're seeing the half of the ball that you're seeing is illuminated. It's getting clear? Okay. Now, as we move forward, this is called waxing moon as we go. Then all of a sudden, the moon goes to about here.
And then we have step right here.
What?
That's
full moon.
But we're assuming that the moon is still, the sun could hit the moon, otherwise it'll be a solar
the sun is much
eclipse.
bigger than the Earth. Right. Yes. You're right. This could be a lunar eclipse. This could be a solar eclipse. If everything is perfectly aligned. What we know is that things are different on different planes. I don't want to get into that.
Right.
That's way beyond what I'm going to talk about. But it's not what we call an eclipse. It's what we call like this mini eclipse. Right. Now, this time you have the exact opposite, and you would see the moon like this, right? As opposed to like that. Now it's the same, but one is facing you this way and one is facing you this way. And as the moon, this is called waning moon, it'll come here. Now, just a side point, this doesn't affect us so much. This looks like a 360-degree circle, right?
Mm-hmm.
In reality, it's really not. For the moon to travel perfectly 360 degrees, it takes about a little over 27 days. But what has happened is, as I mentioned to you, our sightings of the moon are only relevant to the moon in the position of the sun. But we already know that in this 27 days, something happened.
We move.
We moved, or let's say the sun moved, okay?
Mm-hmm.
The sun's not here anymore, it's here.
Mm-hmm.
It moved about, approximately, in a month, 30 degrees, because it moves a degree a day. 360 degrees a year, 365 days, a little less than a degree a day. So it moved about 30 degrees. So if you would do the math, if it can move 360 in 27 days, it takes another 2.5 days, and the conjunction is going to happen not when it's here, but when it's here. Because it has to be aligned with the new position of the sun. So this is sun 30 days ago, this is sun now. So in reality, the circle is going like this, not just one circle. It has to catch up with the moon. Okay? That's pretty much what happens. You're going to excuse my artwork because I'm not really great at that. That's pretty much what happens and the cycles of the moon.
Rabbi,
Yes.
Does the moon go in a perfect circle, or I remember reading that it goes like it's.
It does. You're thinking of the epicycles?
I guess so.
Yeah. Epicycles are not true. That's what the ancients thought, and that's one of the ways they explain it. Harambam wrote about epicycles. It doesn't happen. He did it because he didn't realize that the Earth was moving. So in order to accommodate for a moving Earth and a moving thing, he had to make the moon go around the Earth like this.
But it wasn't because of the sun's gravitational pull.
That had to do with, that's a simple thing that all the Greeks did, because we did it one time on a computer simulated program. This makes me, in other words, this accommodates for this. For this moving and this moving around it, if you go on a computer one time, I'll show you, it almost looks exactly the same. So this is how and to figure out the epicycles was highly complicated. We're not going to deal with epicycles because it's not really relevant to what we want to talk about anyway, and it's not true. So we're going to leave that out. We're not going to talk much about epicycles, but we're going to talk about it. Okay, now, how long does it take for the mean circle of the moon to go around the Earth? So the rabbis talk in the following lengths of time. Okay? Their times are pretty much, they talk about days, hours, not minutes, what we call halakim. Okay? Now, a halak, right, is about 1/18 of a minute. Every halak is 1/18 of a minute. So, a day is equal to 24 hours, as you know. An hour is equal to 1,080 halakim. Okay? All right? So, in other words, that's the way they calculate time. Why did they choose 1,080? The reason they chose 1,080 is, according to Rambam, it is the most divisible number. So it is divisible by every prime can be divided by any prime except 7. In reality, it's not. And he wanted to pick the smallest number that could do that. There is a smaller number that can do that, which Rambam does, which is 360, which is just as divisible as 180. There's a little bit of a complicated reason why I believe he chose 180. I don't want to get into that now. But although Harambam says this is the smallest number that's divisible by everything except 7, there's another number, 360, but for certain reasons he didn't use it. He wanted it a little bit larger. Okay? But it doesn't make a difference, it is what it is. So we have days, hours, halakim. So, the moon, and this is now, we're going to start, there's a few key numbers. When you get these numbers, it's the whole secret to knowing the Haibbur. The moon takes.
The halakim again.
Halakim is 1,080 halakim every hour.
So one halak is what?
One halak is 1/18 of a minute. It's about 3 1/3 seconds. Okay? A little bit more.
Well, repeat that. How long?
Watch. Every day has 24 hours. Every hour has 1,080 halakim. A halak is 1/1,080th of an hour. Okay. Now, therefore, whenever you have, obviously, and this is going to be simple, if I have 2,000, if I do a thing and I have 2,000 halakim, that equals what?
Almost 2 hours.
It equals 1 hour. You have to always make it that the halakim will be less than 1,080. It equals 1 hour and 920 halakim. You can never have a number 2,000 halakim. You can't work with that. You always have to then change it into hours. Just like if you had 25 hours, it's 1 day, 1 hour. Okay? So that's important to know, that you always have to subtract. and make sure that you simplify what you have.
Who started the halakim? Who they used in the time of the Gemara?
It's a good question as to when they started using the halakim. That seems to be in the time of the Gemara. Some of this stuff in the calendar is definitely in the Gemara.
It's not mentioned. Is the word halakim mentioned in the Gemara, or
I don't remember. I have to check. I'm not sure exactly the first usage of headache.
When you say we're taking the mean cycle of the moon,
Meaning because sometimes it takes a little bit longer and sometimes it's a little shorter.
how much are we talking about?
Not much.
'Cause it's
Not much. It
really-
comes at the end of the year. It comes out perfect. I would
Rosh
say
Chodesh is
to a
still-
year. It's in the month. In the month, it's you're dealing with not 30 seconds a year. But it can fluctuate. But that's how it comes back.
Right.
It can fluctuate more or less minutes wise in terms of that.
I mean, but, still,
But in order to figure out the mathematics of the actual conjunction every month and its perfection, it is way too complicated. I'm telling you, just to get through the 9 chapters, and I couldn't find anyone who could teach it to me. I had to hire, and it took me, I'm telling you, just those 9 chapters, which is the figuring, it took way over a year to someone to try and explain it to me. I finally got it. Do I got it now? I have no clue. I have all these notes. I have no idea if I'd be able to do it again. It's highly complicated, with highly complicated structures and figures, and even today. In fact, one of these books is even today, even modern day astronomers sometimes have a trick with it, with everything that we have, to predict the exact actual conjunction every single month. So, it's not simple at all. And you're doing with telescopes and things like that. So, what we do
it
is
doesn't
we go...
automatically adjust itself every month? Say 2 degrees. You said.
What?
You said every month it moves 2 degrees, right?
Right, but that's...
So it doesn't automatically. If
No,
last
so
month
that's just getting back to the same spot as vis-a-vis the sun. But sometimes it speeds up, and sometimes it makes that same side quicker. And the reason is because it's also depending on the angle of the Earth's movement. We know why the moon's a little tricky, because since the Earth is moving, and the moon is moving around the Earth, depending on the angles where the Earth is, it can go a little bit faster or a little bit slower. So, but again, it's not so relevant, because we have established this mean cycle, which is what we do, which pretty much is as accurate as we can get. You know, I have in here, I didn't introduce you to this book. This is a very interesting book. It's not written, it's not Jewish, but it's about calendars. It was one of the first things I read. Isaac Asimov, who was a scientist, and he wrote the book called The Clock We Live On. And it talks about the different, it talks about a lot of what I just said. And he has some very interesting stuff about the Jewish calendar. Yet the end believes that the most accurate calendar of all the calendars, he goes through a lot of calendars, was a Jewish calendar, but it was, in his eyes, needlessly complicated because we don't need to figure all these things out. Of course you don't. If you don't have a halakha, you don't need it. But it's much easier to take a solar year and just slice it into 12. But for whatever reason, we... Now, before, I should say something about that. About, stuff that I'm sure all know, but I'll review it quickly, and then I'll get back to the moon cycles. All the years, right, we know how the Christians write their calendar. They take a solar year, and they just chop it into 12, thereby having a month that means nothing, right? There is no, September 10th and October 10th have nothing in common. It's just taking a solar year and chop it into 12. You could have chopped it into 10, you could have chopped it into 13, they chopped it into 12. And that's what they do.
Any reason?
It's very easy, and it's very accurate. It's a pretty good system. Why? Because it's pretty accurate. It doesn't change much, right? It doesn't change much. You can pretty much predict. And for everything you need to know to make modern day society livable, sunrises, sunsets, things like that, it's very convenient. So it's pretty simple. If you don't have a religious reason, it's pretty simple and convenient. And what you lack is months. Who needs a month anyway, in their mind? Who cares about where the moon is going? It really doesn't do anything except affecting gravitational pulls on the Earth. They don't care.
So was it always 365 days even when it was only 10 months?
No. I don't know that it was ever 10 months. and we'll talk much more about the secular calendar a little bit later, when we get into a little bit more into Kufot and seasons, because that's going to affect the halakha. So we're going to talk about the secular calendar. I just want to, the Muslim calendar, as we know, is